the problem. So this problem is a graphical problem. Alright. So now look at the figure. So you have a position time graph. Okay. So you have points A, B, C and D. Correct. Now the question goes like this. What is the average velocity at 5th second, at 20th second and 27th second? You have to solve it using the graph. Okay. Alright. So now see, when we talk about position time graph, so you guys know what is a position time graph, correct? Okay, now we are looking at the velocity at 5th second, 20th and 27th. Now as you can see in the graph, we don't know 5th, 20th and 27th, correct? But what we know the velocity at 0th second, from the position time graph, and we know at 10th second, 25th second and 30th second, correct? So we have to use this to get the velocity. Okay, now if you look at the graph, from 0 to 10, what is happening? Time is increasing, even the position is also changing, correct? Now, this is changing in a uniform way, correct? So, what we'll do? Now, velocity was what? Change in displacement over time, correct? This was velocity. Now, in this case, at 10th second, what is the position? What is the position? Position is at 10, correct? Or we can call it as 10 meter, right? So 10 minus, what is the initial position? 0. So 10 minus 0 divided by, what is the time we are taking? 10 seconds, right? So 10 minus 0 is 10. 10 by 10 gives you 1. So the average or the velocity at the 5th second will be 1 meter per second. Since this is uniform motion, or this is uniform velocity, I can say at 5th second, 7th second, or even 2nd second, everywhere the velocity will remain the same. That's basically 1 meter per second, correct? Understood? The same way, at 20th second, now as you can see, from 10th second to 25th second, what is the distance or what is the position? It is 10 meters itself, correct? Now again, so velocity at 20th second, change in displacement. So what is the change in displacement here? I am staying at 10 meters and I am not at all moving, correct? So from 10 to 10. So what is the displacement? 0. So 0 divided by time taken. Some time taken will be 15. What is the value of this then? It will be 0. So the velocity at 20th second will be 0 meter per second. Alright. Now the third, which is 27th second. Now at 27th second, if you can see, now from 10 meters, I am coming to 0. Correct? The position is changing from 10 meters to 0 meters. Now what is the change in the position? The displacement? It will be 0 minus 10 because final value is 0 meters and initial value is 10 meters, correct? Right? So 0 minus 10 will give you minus 10. And then what is the change in the time? It is 5 seconds because from 25 to 30 we are moving, right? So the velocity will be change in displacement, which is minus 10 divided by 5, which gives you minus 2 meter per second. Now remember, velocity was a vector, correct? So plus and minus, it determines something. Now in the first value, that is from 0 to 10 meters, it was plus 1 meter per second. And the last value is minus 2 meter per second. Right? So plus 1 says that it's increasing, minus 2 says it's decreasing. Understood? So we just figured out the velocity at 5th second, 20th and 27th. Now, whenever you have any graphical problems, like it can be position time graph or displacement time graph, whatever it can be. So, any problem, just look at the graph. If you have a straight line, as we have from the first 10 seconds, it's a uniform velocity, okay, and it's increasing. The next, from 10 seconds to 25th second, that is, the object is not at all moving. Okay, the position remains the same. From 25th to 30th second, it's coming down, meaning velocity is coming down. that's where you get negative. So whenever you are doing any vector sums, it will become negative sign. Understood?